Assalamu alaikum wa rahmatullahi wa barakatuh. You are once again welcome to online physics class. So today, inshallah, we'll be going to magnetism. Magnetism, and what are the things we will be likely to be looking inside magnetism are magnet and a magnetic material, poles, method of identification of pole, magnetization and demagnetization. When we refer to a magnet, we mean or we define a magnet as a material that has ability to attract a material. For example, as I am holding now, this is what we call a circular magnet. You can also see the shape of this magnet is in form of a circle. Though we call this type of magnet as a circular magnet. So whenever a material has ability to attract another material, so we define that thing as a magnet. So meaning of magnet is that it can attract another metals in particular. So the ability of a magnet to now attract another material, which we call magnetic material, is known as magnetism. The ability of a magnet to attract a magnetic material is known as magnetism. Now, also, what do we refer to as magnetic material? Magnetic materials, they are materials that can be attracted by a magnet. Magnetic materials are materials that can be attracted by a magnet, such as we have nickel, we have iron, we have cobalt, we have nickel. Like as I'm holding, and this is a key, right? So this is a key. So by placing it very close to a magnet, you will see that gradually as you are moving your hand closer to the magnet, shortly it will quickly attract the material. So that ability of this magnet to attract another material is known as a magnetism. And the material that attracted by a magnet is called a magnetic material. So these are some terms we use in magnetism. What do we refer to as magnetism? What are magnetic material and the likes? So we other have shapes of other magnets as well, aside from this circular one. So we have some of magnets that are in form of a rectangular shape. As you have here now, this is what we call a bar magnet. So bar magnet often has the shape of a rectangle. I think you are following. So it is in form of a rectangular shape. Also, we also have another shape of magnet like this now. This is what we call horseshoe magnet. So horseshoe magnet. So these are some of the shape of magnets we can quickly find in our surroundings. Now, what are the benefits or the usefulness of these magnets? Number one is that a magnet are used to make tight seal on the doors of refrigerators or freezer. There are some of freezer or refrigerators that when you open between the doors, the two doors now, there will be some magnets being put inside of the fridge, so that when you are about to close the entire door, it will quickly attract the next one, so that they have put a magnet there, so that the other one can be attracted by the magnet in the first one. And likewise, we will have it in a freezer as well. So in the doors, or even some doors are being used that they will have some magnets put inside of it. And likewise, we also use a magnet extensively in a computer. So they are used in computer to store data. You will see that majority of the stereos we are having, your television, your earphone and the likes, we do have a magnet there, right? So magnet is very, very essential or usefulness in the physical world. So we use it greatly in power generation as well. You will see that when there is flowing of charges, that is when there is current flowing between metals, between wires, you will see that when you have two wires now being attached together, you will see that there will be causing of some spark. After the spark, you will see that they will melt together. So that also is known as, is defined as the magnetic properties of that metal. So all metal will also possesses magnetic properties, which is a attraction, because the main function of the magnet is that it gets attracted to the other metal. So these are some of usefulness of a magnet. Also, we use magnet in what we call MRI. I think you could have heard of that. MRIX. This is the full meaning of this is a magnetic resonance imager. This is what the doctors use to look into the bones or the veins of some of people. So they are using it to form some images, and what they use mainly in that device is a magnet. So it can penetrate beyond the external skin we are having, so that the defaults in the skin, in the inner part of the body, can be seen with the help of that device. So which is the one of the application of the magnet. So these are some of the applications of magnet. We also have some as well. Now basically is that a magnet, it has two poles. A magnet has two poles, which are called the north pole and the south pole. The north pole and the south pole. You can see here now, this is our north pole, this is our south pole. Now how do we say that okay, one side or one point is called the north pole or the south pole? Now whenever we have a magnet and we get an iron filings, you put an iron filings and you put a magnet inside an iron filing, you will see that, for example, let's assume that this is our bar magnet now. So we have iron filings like this, very large. So as you put the bar magnet close to this side, you will see that there are some points at the edge of that bar magnet where the iron filings will be much attracted to by the magnet. So that point where you have much of the iron filings, we define it as the pole. So, and we have two poles, the one at the one side and then the other one, which is, if this one is south, this one will be north. If this is north, this one will be south. So a point where the magnetic properties of a magnet are much pronounced, we define that point as the magnet, as the pole of that magnet. Are you getting it? So we define a pole as a point where the magnetic property of a magnet are strongest or are much pronounced. So that region is called the pole of that magnet. And we have two poles, as I have earlier stated. We have the north pole and we also have the south pole. Now how do we now determine the pole of a magnet? Number one is that we can determine the pole of a magnet by means of free suspension. By means of this free suspension. For example, if we freely suspended a bar magnet like this, if we truly suspend a bar magnet like this now, so we now determine the region where this edge points to. So if, for example, if this is our geographical north pole, as you are to you, this is your north pole, definitely this will be your south pole. So as this bar magnet now suspend, definitely this will be the north pole of the magnet and this will be south pole. And if it is like this, so if this is your north, for example, and this is your north, so definitely the point where your the edge pointing to the south you are, that will give you the south pole of the magnet, and the north will give you the north pole of that magnet. So this is one of the methods of determining of identifying the pole of the magnet. Number one is that by free suspension. By free suspension of a bar magnet. Then number two is by using of a compass. Number two is by using of a compass. What do you mean by compass? Compass is a device used for navigation. For example, now, if you are traveling to unknown places, so if you have your compass with you, or you know how to read, how to interpret the reading of a compass, so you quickly know where you are. So definitely that you won't be able to get lost easily. Okay, so compass is used extensively in navigation and orientation for determining the direction of geographical area. So for example, now this is This is a diagram of a compass. This is a diagram of compass. So we have the north pole, north at the edge, while the bottom will be south. We have the east here, we have the west here. So between the north and east, we have the northeast, and we also have the southeast here, while we have southwest here, and we also have northwest here. Okay, now, so for example now, so if you now suspend your magnet and it points toward like this, for example, so definitely that by placing it close to the direction of your compass, so you know, okay, the point close to where you have your knots on the compass will be the north pole of the magnet, and the other region where we have the other region will now be your south pole of the magnet, because it's pointing to the south pole and south of the compass. Exactly. And also you will see that this compass as well, we use this to determine Qibla in our religion, right? So you can determine the Qibla of a particular area by using of a compass. So these are the basic two methods of determining the pole of a magnet. The first one is by field suspension, and then the other one is by using of a compass. I think you get the illustration now. So also we also talk about the magnetization and demagnetization. Now, what do we mean by magnetization? Now, initially there can be some material that they are magnetic material, that is, they can be attracted by a magnet. So now the process of now making that material to have or to possess a magnetism is known as a magnetization. The process of making a material initially which is not a magnet to possess the characteristic or the feature of a magnetism is known as a magnetization. While the vice versa, the process of destroying the magnetic property of a magnet is known as a demagnetization. So I will give you the method under each of the two ways, magnetization or the other form. So also a magnet, we have some material they are naturally a magnet, while some are artificial magnet. So if a material possesses a magnetism without method of magnetization, we will say that the material is a natural magnet. So we have a basically natural magnet we have is called lodestone. So the natural form of magnet we have is called lodestone, while the other one, which is the artificial magnet, are the one that you get through the processes of magnetization. So they are the artificial magnets. I think you get the illustration. So also now, among the method of magnetization is that method of magnetization. Number one, we have single touch method. For example, let's have a bar magnet. Let's draw the diagram of a bar magnet. So this is a bar magnet now. This is a bar magnet, right? And this is our north pole and this is our south pole. So when you bring a material, this is the material you brought now. So rubbing it like this, continuous rubbing on a pole of the magnet, you will see that they also become magnets. Exactly. So that method is called single method of magnetization, single method. Why multiples of it, one year, we call that one a double method. So among the method is called, we have single touch method. Then the other form we will also have is called double touch method. So single touch method, double touch method, and we also have electrical method. electrical method. Now, electrical method. So if you have a material passing it through a solenoid, if you have a wire being wounded round together, so that's called a solenoid. So placing a material underneath now for a continuous period of time will make the material to become a magnet. So all these are some method of making a material to be magnet. And likewise, the other form, which is the opposite of this, is called demagnetization. And what are the method of that? How do you demagnetize a magnet? Now, one of the method of demagnetizing a magnet is, number one, is called hammering method. Hammering method. Hammering method. Demagnetization. As I have defined demagnetization as the process of reducing the magnetism of a magnet. So one of the method is a hammering method. Hammering method. Hammering method. Now, what do we mean by hammering method? Hammering method is the process of breaking a magnet into some pieces. So, for example, you have a bar magnet now. This is our bar magnet. Very long, a little bit. This is a bar magnet. This is our north pole. This is our south pole. So, if you hammer the magnet at this region, you see that it will cut into two, right? Now, definitely that breaking into two, it will be like this now. So, this is the region it has broken. So, we have north here, and here will be south. So, the other part of it will be like this. So, this is our north again, and this is okay, this is our north, sorry. This is north, while this is south. So we have broken the initial magnet into two now. Again, hammer this one again, and likewise this one. You know that as you are doing that, it will be reducing the magnetism of that magnet. So this is one of the method of reducing the magnets. So then the other method is by heating as well. By heating. Now, if a magnet is being placed in an hot water, so definitely that the magnetism of that magnet will be extensively be reducing. So if you can try that. If you have your opportunity to see a magnet, continuous boiling it inside the water, you will see that often it will fail to attract any piece of material again. So one of the method of demagnetization is called heating method. Exactly. So we also have some other method as well, which are many. So take note, hammering method, you use it to demagnetize a material, and likewise heating method is one of the method of reducing the magnetism of a magnet. And now, so these are some of the method of reducing the magnet. And not to, if you are treating or you are treating it roughly, you throw it, put it outside the sun, and often like that. So treating it roughly make it to reduce the magnetism of that magnet. Now, so those are the terms, and those are the something other magnetism. And now we will now go to what we call a magnetic field. A magnetic field. A magnetic field. A magnetic field. Now, as I have stated, we have many times we use in a magnet or in magnetism. One of it is that we know what is magnetism now. We know a magnetic material, we know what we mean by a magnet, and now we want to define a magnetic field. Now, in physics, if you heard of a field, don't be referring to a normal football field you are aware about. No. In physics, what we refer to a field is a region where the effect of some physical agencies can be felt or dictated. For example, we have gravitational. We also have electromagnetic field. We also have a magnetic field. We have electrical field. So this field means that here in gravitational field, the force of the gravity can be detected there or can be felt. Now in electromagnetic is a combination of electric and a magnet. So that means that a region where the effect of the electrical and the magnetic effect can be felt or detected is called a electromagnetic field. Likewise, a magnetic field. Now, so a magnetic field refers to as a region where the influence of a magnetism can be felt or detected. For example, let's draw a magnetic bar magnet field. Now this is our bar magnet, this is our north, this is our south. So as you have it here, as you have in current electricity that charges will be flowing, likewise there will be movement of magnetism from one pole to the another, because in current electricity charges will be moving from one terminal to the other. So now here is that north serve as the positive terminal, while or positive pole, while south serve as the negative pole. That means that magnetism will be moving from north pole to south pole. So it will be moving like this. So this is our magnetic field. So likewise at the other region like this now. So magnetism will be moving from one pole to the other. Please take note of the direction of the arrow, because it is very essential. It can be drawn without giving the pole of that magnet. So but by mere looking of the direction of the arrow, so a magnetism moves from the north pole and enters the south pole. So definitely whenever you have this mark, this arrow now, point the where it's pointing to will be the negative pole, which will be the south pole, while the pole is moving from will be the north pole. Okay, so we also have another line of force now. So if you have many again, so you have also, this is a magnetic field. Now the region where the influence of the magnetism can be felt or detected. So we can also have another like this, another like this. So this is known as a magnetic field. And what do you mean by magnetic line of force? All this imaginary line you are seeing, though it will not be physically seen. Okay, so these are called magnetic lines of force. They are imaginary lines giving us the pole of that magnet. So as here, this is our north pole, so you have magnetism being moving away from it. So you have magnetism moving away from it, and this is our south pole. You have magnetism coming inside of it, I think, as you can see now. So this is one of the example of a magnetic field, that is the region where the influence of the magnetism can be felt or detected. Exactly. So inshallah, in our next class we continue from the other times we use in magnetic field, and then we draw some of the patterns of a magnetic field. If you have two or more bar magnets, how do you show the attractive force of repulsion or attraction in that field as well? So, and likewise, after we have through with that one, we also discuss about a neutral point and then the other things related to magnetic field. So I hope you have learned a lot today. So if you are opportune to see a magnet around you, you can practice the method of magnetization and also the method of demagnetization. Okay, so and also the parameter we have given, the definition of the terms used in magnetic we have stated. Also try to remember it and try to make it as part of your physical part of what you have gained today. Okay, so I pray may Allah make it easy for every one of us. So assalamu alaikum wa rahmatullahi wa barakatuh.